And it looks like it's on. So welcome Aaron, welcome everyone else to SQL Friday. This is SQL Friday number 148, and Aaron is a first-time speaker on SQL Friday, and has woken up, I would say, more middle of the night than early in the morning. And sorry for the echo. It's gone now. Yeah, I I don't have a good introduction of you, so I will leave that to you. I know that you live in Utah now that we have chatted a little bit, but welcome. We're going to talk about changing, I would say, slow code to fast code, but changing procedural SQL to set-based SQL, which is a nice topic, I think. So the stage is yours, Aaron. I will monitor the chats in YouTube and Teams, and all I need to know from you is, do you want to be interrupted during the talk, or do you stop for questions?
Oh, sure, sure. I can always be
Cool.
interrupted because it makes it more like a true live interactive session. So I appreciate
Sounds
that.
good.
All right. So greetings, everyone. Appreciate you joining us for this session. Um, I I know that you may have heard us talking earlier about both Postgres and SQL Server. And I will say that these concepts apply not only to SQL Server, but also to Postgres or even to Snowflake or whatever your other environment is, because it's a very uh, common problem among relational database management systems. Being able to identify procedural code and be able to convert that to a set-based operation to make it far more effective. So you're probably wondering just a little bit about who I am. So I'm known on the internet as SQL RV. I picked up that moniker because I travel the U.S. In an RV. I've had various types. I've had a fifth wheel travel trailer, and also I currently have a motorhome. So I've traveled around giving presentations in uh, conferences, user group meetings, etc., for not only SQL Server but also Postgres and professional development topics. I'm currently Director of Data Services at Honest Health, based in Nashville, Tennessee, in the U.S. I've also been a Redgate Community Ambassador since 2023, and I've been at a few speaking events in the, I'd say, past 12 years, 13 years now since I've been giving presentations. I actually started doing so to help myself get over the fear of public speaking. And I'll let you know when it actually works. I got a Bachelor of Science in Computer Science at Ball State University in Indiana. Uh, got a master's in computer information while I was still working in manufacturing and warehousing industries. But when I got into healthcare, um, I found out that not only could I do much to save the bottom line, could actually do much to save lives. And so, because of that, I went back and got a master's in health informatics, and then went on and got a doctorate in healthcare administration because I really love being able to make that impact to people. And I've been doing this for over 35 years. I won't get too much more detailed than that. I'll just leave it that way. So here's something to consider. Uh, Audrey Hepburn said, "Nothing is impossible. The word itself says, I'm possible." Now, this kind of a play on words is great in English, but it doesn't always necessarily translate to other languages. But the point is that uh, you can always do something that is possible to be able to make things happen. So today we're going to talk about a few things. First of all, procedural versus set. What's the big deal? So we'll talk about how procedural processing works and how set-based processing works and compare the two. I'm going to use an example of a string split. Now, I know that SQL Server 2022, I believe it was, came out with a string split function, which is fine. But for many, many years, we had to deal with that in other ways. But I'm going to use this as an example of how we can take a look at going from a procedural processing to looking at a set-based processing. So we'll look at the scenario itself, a procedural method, the recursive method, because a lot of people think that, oh, well, I can use recursive CTEs. It's all in one query. It's set-based, right? Not exactly. So we'll take a look at that, and then we'll look at an enhanced set-based method. And then we'll have a few closing thoughts. So the first thing, procedural or object-oriented processing. So what is the big deal? In procedural processing, data is very abstract because the structure or the organization of the data is not the point of the exercise. The idea is to be able to make code as easy to develop, easy to implement, easy to maintain as possible. And to do that, it's usually separated by several layers of abstraction. So in object-oriented coding, you can have a class with methods and properties, and then you can build up upon that, but you don't need to know what the underlying working is of that because you just use that as a black box. It's more concerned with what to do and how to do it. So there is a step-by-step processing to procedural programming. You use statements and loops and object manipulation and other techniques to be able to make the code do exactly what you want it to do. There are different logic paths based upon data attributes. You can have conditions and if statements and branching to be able to do different logic on that. And when you really look at it, it does a row by row processing of data because it'll take a row, processes it, go to the next row, process it, etc. But the thing is that it provides total control. You know exactly what the code is going to do, and it will be consistent every time in doing that code because it doesn't matter what the data is, the same steps and same operations each and every time. Now, let's look at the other side. Let's look at set-based processing. Set-based processing is more about describing what should be done. It tells you what the operation is, like whether you're going to do a select or an update or an insert. And it identifies the conditions. And that would be, what tables are going to be referenced, what the conditions are, the where clause, etc. So as you're building your SQL statement, you're describing more of what I want to accomplish, not necessarily how. You allow the engine to actually determine the most optimal method for performing your operation. And it's going to take a look at various things. It's going to look at your data structure, how it's organized, how much data you have. It's going to look at previous runs of a particular query or procedure to see how it performed. And it may change the way that it handles a situation based upon the data. Because as you know, every data environment changes over time. It grows. You add new tables, you add new indexes, you may tweak a table structure, you may split a table. Your code may not change, but how the engine performs its process may change over time. And that's the whole beauty of it, is allowing the engine to be able to do what it determines needs to be done. You're more concerned about what gets accomplished, not necessarily how. And so it frees the developer from all these specific mechanical details. you don't have to worry about all of these changing conditions. If you're doing this in a procedural method, if your environment changes, but your code doesn't, it's still going to perform the same way that the code was developed for. And you may have to go in and change the code or tweak it over time as situations change. And set-based processing allows you to not worry about that because the engine will take care of it. And so as those conditions change, you don't have to go in and change your query to make things still work the way it should be. So in set-based processing, the engine itself, the relational database management system, is optimized to select or manipulate record sets as a whole. And especially in SQL Server, it's often at the expense of operations. For example, you may notice that when you go to perform loops and procedural code in T-SQL, yes, you can do it, and you can do it just well, very fine. But it's not quite as efficient at doing that. That's why, for example, if you do a lot of string manipulation, sometimes it's better to create a CLR in C# to do that processing. Yes, C# is very procedural, but it's a lot more optimized to do string processing than T-SQL. So there are some trade-offs. But it also implies a paradigm shift because especially if you started out as a procedural programmer, you're more used to telling it what to do, but you need to focus more on telling it how to do it. I'm sorry, it's telling it what to do instead of necessarily how to do. So there may be some challenges that you have to consider for what's happening under the hood. So the point is, it's like Jeff Moden said, stop thinking about what you want to do to a row. Instead, think about what you want to do to a column. So when you think about it from a column perspective, you're looking at the data as a whole, or at least for that column as a whole, not necessarily each row of that data. So let's take a look at our string split scenario. Well, actually, first I'm going to ask if there are any questions before I continue.
There are no questions in the chat, no. But I have a comment. I'm glad you mentioned Jeff. He's
Sure.
like, without knowing it, Jeff is my mentor because when I started learning SQL Server, I spent a lot of time on ask.sqlservercentral.com, and Jeff was one of the
Yes.
gurus on there. So, and he's actually been on SQL Friday as well to do a
Excellent.
talk. So yeah, great guy. Thank you.
Yes, yes, he is. He's a good egg. Sometimes a bit cracked, but he's a good egg. um, I say that because I tease my friends, so I can get away with that. So let's take a look at excuse me. Let's take a look at this split string by delimiter. I mean, here's a very simple situation. We want to be able to have a string that's delimited by some method, and we want to split that out into rows. We want to allow for a variable string length as well, because otherwise it wouldn't do as much good. We also want to have variable length delimiters. For instances, I may want to be able to use, say, something simple as a comma, or I may want to be able to use a multi-character delimiter. If I'm especially trying to separate something like HL7 messages or something of that nature. We want to be able to return a table that's consisting of the sequence number of the string segment as well as the string value. Because often, and one of the things that the string split function in SQL Server, it doesn't return initially, the initial version of it did not return the number. And so when you got the data back, it was coming in, here's just the data itself. You didn't know what order it was coming in. Sometimes it's very important to be able to know the sequence in which those segments come. I see that has been corrected since then. Is now an optional feature on the string split function that you can specify to return the index along with that. So let's look at the basic process. What we're trying to do is to I'm showing a logical process or a procedure to be able to do a string split. So I'm going to be kind of generic. I'm not going to use a specific programming language like C# or Python or JavaScript or whatever. So I'm going to identify a variable. I'm going to say the new string segment is S, and the delimiter index is going to be from S to I. So in S, it's going to be I to represent the index, and the sequence number is going to be N. So I want to be able to search for a delimiter. So I from the string, and I start at position I, and I want to increment the sequence by N, and I want to replace the source string with the remaining portion and insert the result into a table. So again, a very procedural process to do this. And I'm going to repeat step 2 until the string is empty. So for example, here is the string, and I have A through O in the alphabet, and I'm going to use as my delimiter the less than greater than sign. And so what I want to get out of this is I have a table or a result set that shows A and then BC and then DEF, etc., all 5 segments of the string that I've split. This is my objective for this exercise. So here is some code for SQL Server that I could use to implement that particular algorithm. And as you notice, it is using procedural code because I have a while loop and I have conditional logic, and I'm doing exactly what that procedure algorithm was intended to do. I'm setting my variables. Of course, I didn't use the same single letter variables here as I did in the method. I actually made it more SQL Server-ish in doing so. But I set my indicator here, or my index here, and then while I still have an index, while there is still a delimiter to be found in the string, I will process through that and storing the results into the table for the sequence and the string segment, and I will continue on until there is nothing left to process. This procedure works. It works. Actually, I created it as a function, and you'll see that I did name it as it's a multi-statement table of value function with a while loop, string split. Now, I could also use a recursive CTE. A recursive CTE, though, makes calls to itself as a hidden loop. You may not realize it, but every time when you look at the levels of recursion, it actually loops through itself to do that. It actually requires about 3 times or more of the resources that a simple while loop would have because of the behind the scenes data storage that is required. And the reason why it takes more processing than a while loop is because the recursive CTE is a generic process. It's intended to work in pretty much all circumstances. And so there are a lot of housekeeping items that are set by the engine behind the scenes. So it does take quite a bit of effort to make it easy to use. And each loop requires the results of the previous loop. So it has to keep storing all of that information from each iteration. And if you're not careful, you can actually lock up a server if you don't specify what your maximum levels of recursion are. In other words, what is the number of loops that are the maximum time I want to go through that? Because if you're into um, a pretty large data set, or you make a mistake and end up making yourself into an infinite loop, then yes, you can tie up your server and bring it down. Um, how many people can actually say that they've brought down the server because of that? I know when I was beginning to do this, I did.
Yeah, same here, more than once. But on the other hand,
More than
I've
once.
brought down servers with while loops. It's as well because I forgot to like set the new condition for whatever
Yes.
I'm comparing in the while loop. So
Yep. I've done that as well. It's something that we've all faced. So instead of doing a recursive CTE, for performance sake, you're better off using a simple while loop. And because really only one pass per level of recursion is needed. And the results can be more easily preserved between the levels because you're preserving only exactly what you need and not having a pretty uh, hefty process involved to handle the recursion. So here is an example of the recursive method. And so this is my inline table value function, the R is for recursive. And I'm using this to establish, there's my base, oops, my bad. Here's my base condition. And then I'd have my union all with my recursive part where it's referencing the CTE itself. And again, the code is a lot simpler than the procedural method, but it's still a procedural method, whether you realize it or not. So how else could we handle this? Well, we could use a set-based method. And in this one, I am actually making use of um, the fact that let's say we don't have uh, a a sequence number generator. So I'm going to build a sequence number generator or an internal tally table, if you will. And so I am starting out with 16 rows. That's what this first CTE does. And then the second CTE says I'm going to cross join those two to give me 256 records. And I will do that again to get 65,000 records. So basically it's e to the fourth. And I can go e to the eighth to get me over 4 million rows. Now, that doesn't mean that every time you run this, it's going to build up 4 million rows of numbers for you to work. SQL Server is a lot smarter than that. If you only need, say, 200, then it'll run only the first two CTEs and the others will be ignored. So it's actually really good about that optimization. So in my segment, then I'm going to specify my first spot, do my union all, and then do the second. And then I will get my major selection here to get the data. But have you noticed something? I'm still doing it's not quite a CTE because it's making a reference to the other CTEs, but it's not quite yet set based in the most optimal way. It is set based, but still not optimal. So let's take a look at what we can do to refine it even further. I can use the generate series function. Now this is something that SQL Server implemented. I think it was, I can't remember if it was 2016 or 2022 that it introduced the generate series. But other environments such as Postgres had this for quite a while. And it allows us to be able to generate a series of numbers, as you can imagine, without having to use the CTEs. And so now we can just focus on the segment portion alone. We can get our first use case and then get our generate series for the remaining cases. And then perform the final query against that CTE segment for what each of the segments are within that string. Now, you may have also noticed that I make use of window functions. I make use of the lead function so that I can see what is coming ahead in the query. And as you may know, that the window functions actually perform its operations on the result set of the query. So it's after the query has been performed, it then looks at the results and adds its information on top of that based upon what's in that data. So we're not actually trying to perform the data, the query in real time and looking ahead at what's going to happen. So we're looking at, trying to process something twice. It's actually processing the query, giving you the results, and then the window functions perform on top of that result set. So it makes it very, very handy and efficient too. So let's take a look at a demo. Now I will share something with you here. I set up an environment that I wanted to be able to show easily. So I used a Jupyter Notebook type. Normally, I would have used something like Azure Data Studio to perform this. In fact, that's what I used to create this. But I have to admit that my laptop actually crashed last night. Uh, so very frustratingly, so I'm had to set up a different method to do this. But it still serves the same purpose. So when we're talking about how is it that this string split thing works, let's take a look at it. So again, we have our string that we started out with and specifying what the delimiter is. So what I want to be able to do is, and I'm going to continue using the generate series function that I just described earlier, because it makes it really easier to use. And I want to say that I want to look at it from the very first character to the last character. So this is the length of the string. So this length here, including the delimiters, is actually 23 characters. So as you can imagine, I actually get 23 rows that were resulting in this data set, which is what we were expecting. And it identifies the string itself, what the delimiter is, the string length, and the length of the delimiter. And we're going to make use of that. And we're going to show that for every 23 rows. Now let's go a little bit further. And we want to calculate the segment, start and filter only for where the delimiters are. So I want to know where each delimiter begins. And so I use the same query, and I'm looking at the generate series. The difference here is that I'm going to put a where clause on it. And I'm going to say where the delimiter is. So basically where the start of the delimiter is for the string. Now, because I have only 4 delimiters, I now have only 4 rows. So it shows the string itself, the delimiter's length, and the position in the string where that delimiter starts. I'm sorry, not the delimiter, but the string after the delimiter. So in this case here, I'm actually showing the beginning where BC starts. And for the next one, showing where the D for DEF starts, etc. So it's the beginning of the segment after the delimiter. And then in the next one, I want to get the start of the following segment. I want to be able to look ahead. As I mentioned earlier about the window function, I'm going to make use of that to see where the next segment begins. So I'm going to add to this query the lead function. And I'm going to look at that value, and I'm going to look at the next one. So here, again, like previously, the first segment starts at 4. It's this one here because it's right after the first delimiter. And the next one starts at 6. And then I go to 8. Oh, I'm sorry, not the next segment, but the next delimiter starts at 6. Because I want to know where that next delimiter is so I can determine the length of my segment. Because if I start at 6 or start at 4 and end the delimiter is at 6, then I know that I have 2 characters for that string length or that segment length. So then I want to look at the value for the next segment on the last row, because you notice that here it is being null. Why? That's because there is no delimiter at the end of the string. So we have to create a special use case for that. And that says it comes down to here that I fill that in. So 6, 11, 17, and then now 26. So it's looking at the end of this string right here. And it's acting as though, even though the string length is 23, it's acting as though there were a, how should I say, like a phantom delimiter at the end of the string to make it easy to work with. Okay, now I need to add a special use case. Notice that I never took care of the first segment. So I have to add a condition here in my loop to handle the first segment. And then I add that to the rest of those that I've been working on for the others. And so I add that on here. So here's my first segment, starts at 1. And then the delimiter, or the next segment starts at 4, and my segment length is 1. So it actually calculated what my length is here. And this one, for the next row, it calculated the length is 2 for that segment. And here, the segment starting at 8, it has the length of 3. So what I did is I added the ability to calculate the length of that string segment. Now I know what each of the string segments are, where they start, where the next segment starts, and the length of each segment string. Now I want to be able to get more information. I want to get the segment value itself. I'm going to pull that out. So I add to my query the ability to look at the not only the next segment, but also what its length is, and to be able to pull that data out. And so here for each row, I've identified the segment itself, what the length of each segment is, and even looking at the special use case of the first segment and the special use case of the end of the string. Now I can complete this by saying I don't need all the other information. I only want the sequence number and the value itself. So I can remove the other things that help me to determine how this query worked. And so I cleaned up what I'm selecting from in my final result. And now we have the result set that we were looking for, where the first segment is A, second segment is B, C, etc. for the string length. Now, I will say that we'll make this code available so you can take a look at these queries and understand how it works for each step in the way. This hopefully shows you a refinement of from the first query to the last of how this actually got built up and put together. Any questions on that so far?
No questions. Well, Alexander asks, can you share the demo file? But you already said you will, so.
Yes. Yeah, I'll be happy to share that. And I'll share that with you, Magnus. And also, I should say that this information is also available on my website. If you go to SQLRV.com, you can get that and also my other presentations as well.
Cool.
All right, so let me get this out of the way. All right, so knowing how to be able to do this is great. So how can we, besides just identifying what procedural processing are, what can we actually do to make the migration from procedural to set-based? Well, the first one is to look for ways to eliminate loops. Now, I'm not saying that all loops are bad, but I am saying that sometimes loops can get in your way. They can be a crutch. And remember that recursion itself is really an expensive loop. So I'm going to suggest that the generate series function is going to be your friend, because you can make all sorts of previous loops to be set based. And the multiple rows procedure that I showed you in the example is really how set-based queries work. Notice that every one of those operations could have been a loop to look for the next delimiter, etc. But instead, we use the generate series to make it a set-based. If you're looking for articles on this, Jeff Moden, as we talked about before, has a number of great articles on tally tables. And before the generate series function was available, we would actually create a table that had just the sequence of 1 through whatever in that table, so that we could join it into our queries and allow that to be our loop, if you will. By doing this, we reduce or eliminate a lot of variable usage. Notice that when I did the procedural version of it, I had a lot of variables and a lot of variable manipulation that had to be performed. Instead, we can now capture as output columns from the query and make use of subqueries if we need additional transformations. The other thing is it allows us to be able to consolidate multiple statements together. When you're performing procedural code, a lot of times we're more concerned about what each particular step is doing. And in SQL, we can actually combine multiple statements to perform many operations at once. So we process through the data at one time instead of multiple times. So I just want to give a few reminders when we're talking about procedure programming. Obviously, it's not set-based. It is intended to have greater control over the processing. I'm not saying that all procedural processing is bad. I'm not saying that at all. I'm just saying that it's not always necessary. Obviously, if you go under the hood of a relational database engine and you look at the code, you're going to see some procedural processing in there. And it's because it's the nature of how computers work. But the engine itself takes that procedural processing and makes it set-based, so it is actually more optimal. That's why a lot of people spend a lot of years on optimizing relational database engines. The first version of a relational database engine was pretty clunky because it used a lot of procedural processing. But a lot of education, a lot of learning has happened over the years, and those database relational engines have gotten to be pretty efficient. Procedure processing makes use of loops and recursion and string-based manipulation. That's a great string-based manipulation is a great thing to do for procedural programming. The first time I did something with natural language processing, I did that I was back in the days of C programming, and I was able to tweak that to a pretty efficient process. But there was no way that that type of operation could be performed in a relational environment because it's very, very complex. Procedure programming is awesome with small amounts of data at a time. Like I just mentioned with the natural language processing, if I have a string I want to process, it can do that just pretty quick. Now, if I'm going to take that and say I want to do natural language processing for an entire book, then that's probably not as efficient. That'll take time to process. Relational database engines are set-based, so they are actually more efficient when processing large data sets. I've seen people say, well, I've got a procedural process versus a relational process, and the relational process takes a lot longer. And then when I look into it, I realize, oh, it's because your data set is pretty small. So yes, um, you know, procedural processes can be very efficient in small data sets. But I liken it to a train engine. A train engine may be slow to start, but it can pull a lot more weight than a pickup truck can. Um, in relational database engines, it can generate dynamic and efficient execution plans because it's always looking at the environment, the circumstances in which it's performing. And because of that, it will outperform procedural processing with those large data sets. But unfortunately, not everything can be done as a set. And so that's why, uh, you know, SQL Server has T-SQL, the transact SQL, the relational part, I'm sorry, the procedural parts of it. That's why it allows for loops and, if statements and all those other procedural type processing, because a lot of times it's really necessary. The important thing is to use the right tool for the right job. That's something that my dad kind of ingrained on me as I was growing up, and he was showing me how to make repairs in the home and stuff. And he said just because a flat bladed screwdriver kind of looks like a chisel doesn't mean it makes a good chisel. So we want to use the right tool for the right job. So I did provide some links in this presentation when you get a chance to download it that will give you some more information on understanding set-based logic. And there's a few links also about converting procedural code to set-based logic. I would also recommend taking a look at the resources you have available on SQLServerCentral.com. There's just a ton of foundational logic in there that is just amazing. So actually, I got a sponsor slide. Normally, I don't know what sponsors we have, but we always want to thank them because without our sponsors, we wouldn't be able to do events like this. And I have some contact information here as well. When you get the presentation, there are some links for some free ebooks. Some of them are dated, but many of them are still very, very useful. And I would appreciate feedback on this presentation. Even though I've given presentations for years, I still learn something new every day. And people always point out things to me I never considered. So your feedback is always very much appreciated. And I've given you some contact information as well. Like I said, you can go to SQLRV.com. There's also has some videos on YouTube that are available to take a look at that have been previously recorded sessions. So, Magnus, do we have any other questions?
No questions. Let me look in YouTube to see if we have anything there. No, but I did share the link to your webpage in both this chat and in the YouTube chat. So I guess in the YouTube one, that will be in the video so that people can see it. With where there are links to download the presentation material and so on. So thanks for that. Regarding the sponsors, I run this from my home on Teams. So the only thing that my company sponsors is the Office 365 license, so I can use Teams basically. So it's low budget.
So you are the sponsor.
Yeah, I guess, but and
so you are very much appreciated.
and I take my lunch hour on Fridays to do this. So I guess that's the big thing. I don't eat on Fridays. But that's okay.
So it's a fasting Friday.
The history behind this event is the Microsoft Sweden used to run something they called Thank God It's SQL Friday, which was before we had Teams or Zoom or anything. So half the times they had to cancel because the speaker couldn't connect to whatever software they used to do the broadcasting. And then they switched, so the speakers had to travel into the Microsoft headquarters in Sweden to do the broadcast from
Oh
there. And
wow.
Uh, but I like the idea because we would gather where I worked back then in Statistics Sweden. We would gather in a conference room and just grab a sandwich and have lunch and listen to good presentations. So I figured now that it's so easy to set up a Teams meeting and just spread the word, it's nice to have something that comes back. It's only 1 hour. It's not a full day event, and just being able to, you know, get good presentations like yours and in the convenience of my office chair, basically. So,
Yes. Well, I appreciate you and I appreciate everyone that attended, because you know these are really a lot of fun to put together. Like to be able to share, and I loved being able to see presentations by other people because I get different perspectives. Every time I see a presentation, I learn something. I've been doing this, like I said, for almost 40 years,
mm.
and I still learn every day.
I joined after having done the official Microsoft courses. I was teaching them for a few years, and I went to a conference and I attended a pre-con with Itzik Ben-Ghan on it was the basics of SQL, like how does the SQL language actually work? And then he asked me like, what are you doing here? You're teaching these topics yourself, and listening to a good teacher brings me a lot of ideas on how I can explain kind of complex topics in a simpler manner. So it's even for topics that I thought I knew well, it's really nice to get another angle on it, I think.
Yeah. I just want to reply to the comment. I saw one of the comments about the GitHub, and that's something I should put on here. I do have a GitHub link as well,
All right.
because that's actually where I store my presentations that the website references. So I will include that on the next time. But yeah, it's as you can imagine, it's
Uh-huh.
slash SQL RV.
Yeah, I'll just type the link here, github.com/SQLRD.
Yeah.
So, oh, that's a nice picture of a
Thank
map.
you. Yeah, that was I was at the 2023 Past Summit conference in Seattle,
Mhm.
and uh, Pure Storage was taking photos of people and then using AI to render them into a SQL hero.
All right.
And so that was my image that they generated. They actually made my beard even fuller and gave me hair. It was great.
I mean, I wish it could do that in in real life to me.
Yes, exactly.
I miss having to worry about my, if I had a bad hair day or not.
That's true. Yeah, I don't worry about it anymore either.
That's by the way for anyone if you are a DBA and you are close to the infrastructure side of things, look at Pure Storage because it's kind of amazing the speed you can do physical I/O on a Pure Storage array. It's I can't even believe how fast it is.
I love the fact that they're able to take advantage of a lot of technology to replicate data real fast. It's not because they actually replicate it, but they have multiple pointers to the same data
Mm,
that make it far more efficient. So they can give the effect of multiple copies of the data, but it's still only one copy.
yeah.
And I think that's pretty cool how they do that.
Yeah, and they're also a storage company that they have a lot of people working for them who understands databases. So they really know the day-to-day job of a DBA and build solutions for that. So it's cool.
Yep. Yeah. In fact, one of my good friends, Andy Yun,
Mm.
works at Pure Storage, and I've worked with him for many years in SQL Server. So that. Yeah, they do a lot of work with SQL Server and other databases.
Yeah, and I would say, I mean, if you go to any conference, you would probably see Anthony Nocentino and Andrew Prusky and then Yoon, those three and tons of other people, and
Yeah,
they know SQL better than I, all of them.
yeah, that's true.
Cool. I'm heading off to a meeting that starts in 4 minutes.
Okay,
Thank you so much for coming to SQL Friday. Hope to see you
thank
in
you.
person at an event
Yeah.
someplace.
Oh,
I'm probably going to New York. So if you're coming, then I'll see you there. Otherwise, some other place.
okay. There's actually a question that was the session recorded. I forgot to ask if we were able to record it at the
Oh
beginning.
yeah, it is live streamed. So let me just grab the link to the stream and put it into the chat. Um, I
Awesome.
used to do recordings and then I spent like 2, 3 weeks worrying about not having edited them and published them, and people asked me questions. So I started doing live streams, and then basically what you see is what you get. If the quality of the stream isn't very good, then it's still what's going to be out there, but it's going to be out there immediately.
Awesome. Thank you.
So there it is. That's the link to the live streams. Have a wonderful rest of the day and wonderful weekend. And I'll see you around.
All right. Thank you. Take
And
care.
you. Bye.
All right. Bye bye.